So in this house, built in 2020, is the sub panel, and it's in the laundry room. Typically you'll have a sub panel in a garage, but they're putting them in laundry rooms more recently. So we're gonna take this cover off with these 4 screws, and we're going to take a look inside. You might notice initially that we've got all of our breakers marked per location, which is correct. And we've got several arc fault and ground fault circuit interrupters. Ground fault circuit interrupters, what they do is they will trip if the system senses that you have been shocked or you're being used as the ground, and they will trip based on that. The arc fault circuit interrupters are a little more complicated. They actually measure the sine wave in the circuit, and if there are over, I believe it's 8 to 10 60 hertz cycles in that sine wave, then what they do is they will trip, and that indication of the sine wave that's being measured is simply what a circuit may do if there's a fire or an arcing or a sparking situation. So these measure that type of characteristic in the circuit and will trip based on what it thinks might be a fire. Those are now required in all common areas, dining rooms, living rooms, family rooms, as well as bedrooms. They started off in just bedrooms, and then I believe it was 2011, they went to all common areas. Ground fault circuit interrupters can be used as a breaker or as the outlet that has the test reset button on it. In this case, we've got the laundry room, the washer and dryer connections, and this says dryer, but I don't think that's correct. Oh yeah, it is. This says dryer, dishwasher, and washing machine. So this is for the gas dryer, I'm assuming. This is for the washing machine. This is for the dishwasher. I'm surprised I'm not seeing one for the disposal. Oh, there it is. So the disposal is down here. It's just using a different type. This may be a combination arc fault, ground fault. It's not clear. So we'll open up the panel and we'll take a look. Panel cover open. We have a lot of crazy stuff going on. We're going to start with power coming in. So we have power coming in through the service conductors that are attached to the sub panel breaker at the main electrical panel. The main electrical panel carries 240 volts. That's why your breakers out there are twice as big. They're that wide as compared to that wide. This is a 120, 120, 120. Sometimes you'll see a 240 in the sub panel as well. And sometimes you'll see 2 of these that are trip tied together with a pin between those 2. And that is basically saying it's a 240 breaker. The trip tie is important because if this one trips, it's got to pull that one with it. So what you've got with your service conductors is you've got 2 hots coming in. That's feeding these 2 bus bars here and here. Those bus bars go down and they feed electricity to this point and this point. Another one over here that this column is attached to. So that's how you get power to the breakers. On the main electrical panel, I show you how they pop the breakers off in order to replace those, which I do not recommend you do unless you're qualified to do so. I'm not going to do it in this case. The other components you have is you've got a bridge from here across to here connecting these 2 buses together. A bus is simply a bar with a bunch of screws in it that a lot of connections can be made in. So all your neutrals are tied into here and here. Your grounds at this point must be separated from the neutrals. At the main electrical panel, they must be connected. That controls what's called objectionable current. I won't go into that because that's a theoretical explanation that we are not probably ready for. So beyond that, you come down to behind all this stuff, you see your grounds. Those are grounded or bonded directly to the back side of the panel by it being attached directly to it. You'll notice that the neutrals are floating on this black insulator panel. They do that because they have to disconnect the continuity between the neutral system and the grounding system at this sub panel. So that's basically how it works. And from each breaker, you've got a hot wire going out. In the case of ground faults and arc fault circuit interrupter breakers, you have to have a lot of neutrals that are going into the back side of the breakers too. That's how they work. So each one of the hot wires is being fed through the service conductors, down the bus bar, into the breaker, and out the breaker to a hot wire. Those go up through the top and bottom, and sometimes the sides of the sub-electrical panel. Each one of those has to have a bushing so that the sharp edge of the punched out hole Like that one's not punched out, that one's not punched out, that one's not punched out. But when you punch out a hole like this, you got to have a bushing. That bushing prevents the insulation from being cut by the sharp edge of the metal. So those little bushings are required. Also now, you cannot run all of these through that main central hole. Only the service can come in there, and then everything going back out has to go through individual holes. That's now required. You won't see that on older units. And then there's one at the bottom going out to another circuit. So that's basically how the sub-electrical panel works. And please look at the other videos on the main electrical panel and other inspection files.